Okay, so here we have a general form of the class. You're gonna have the keyword class, and then you're going to have to give your class a name, and then the body of the class would live in between these two curly braces. Now, there are two things a class can have, either variables or methods. So here we define two variables which when they are in a class, they are called instance variables. Now these can be really any variable type and you can have as many as you want. And the other thing you can have are methods. So here we have an example of two methods. You can have 0 or more in a class and they can have different return types. They also can have 0 or more parameters. Let's go ahead and create an actual class. Let's make a new class and name it Pokemon. Alright, so here we see a public class, Pokemon. But this is an empty Pokemon class. So let's write our instance variables and give our Pokemon a name and a level. Now let's write a method that doesn't return anything and call it attack. And in it, we're just going to print out the name and attack. Okay, so this class is now defined. This class will be used as a blueprint for creating other objects. How do you declare and initialize objects? Well, first you want to just type the name of the class, and then you want to give your object a name. And then you want to actually create the object itself, which uses the new keyword and the class name. So in our case, how would that look? We type Pokemon, which is the class name. We have to give our object a name, P1 equals new Pokemon. Okay, so Java actually reads the code from right to left. So what's happening here is, first we're creating this object here. So Java is going to get into the memory and it's allocating space to create this object. And then it's setting it equal to this Pokemon variable. So now if we ever want to access anything in our Pokemon object, we use this P1. So how would we do that? Let's take a look. So now if we want to set the name and the level for our object, we would do something like P1 and then we would use a period, which is called a dot operator. So we do dot name and then give our Pokemon the name. So let's write Pikachu, and then we give it a level. So let's say we give it a level 10. Now let's go ahead and print that out. We see that it says Pikachu 10, which is what we expected. So now we just have one object, but you can create as many objects as you want. So let's create another one and call it P2. Can name it Eevee and give it a level of 20. Now let's go ahead and call the attack method. So now if we run this, we will see that it will say Eevee attack. And we should add a space here. So if you run, you will see that it's now properly formatted and it says Eevee attack. So an important note here is P1 gets its own name and its own level, and P2 gets its own name and its own level. If we change the variable for P1, it does not affect anything in P2. That's really one of the fundamental principles of objects. Alright, so the next thing we're going to go over are constructors. Sometimes when you create an object, you want some sort of code to happen, and maybe you want some variables to get set initially. So that's where constructors come into play. These are special methods that get invoked as soon as an object is created. So if you go back to our Pokemon class, how that's going to look is it's going to be its own method. It's not going to have any return type. It's always going to be the same name as a class. So in this case, it would just be Pokemon. We have our parentheses. So say initially, when we want a Pokemon to get created, we automatically want all of them to be set to level 1. So what we would do here is we would just say level equals 1. So now when an object Pokemon is created, this function gets called and then the level automatically gets set to 1. Let's take a look at an example. So let's get rid of all of this and print out the level of P1. So because a constructor is used, the level of P1 is always going to be equal to 1. If no constructor was used, it would be equal to 0 by default. So we run the code and we see that 1 gets printed. Now say we want the user to give us a name and a level. How would we do that? So what we could do is we could add another constructor that has parameters. So let's go ahead and do that. In the body of the method, we'll just set our actual variables in the class equal to what gets passed in as the parameters. Alright, so let's go back to our main function. So let's go ahead and create an object passing in arguments for our constructor. So how that would look like is we just create an object like we normally would. Now when we want to pass in the variables for our constructor, and in the parentheses, we just pass in a name and a level. So the first argument refers back to the string p name, and the level refers to the p level. And then our name and our level, our instant variables, get set to these arguments. Now let's go ahead and print this out. So here we're going to just print out p1.level, and then we're going to call p1.attack. And they are printed on the same line, so let's go ahead and give us a new line. So here we see p1.level, which is 25, and p1.attack, which is EV attack. So we see now that the EV and the 25 get set because we passed these into the constructor. Now we will talk about the this keyword. So let's say for some reason in our constructor we wanted to call this string name and int level, and then in here we want to set this name equal to name and level equal to level. You'll see how this gets kind of weird, because name is the same as our instance variable name, and same with the level. So which one does it use here? And what actually happens here, that it always uses the most local variable. So in this case, it would use the arguments that get passed in. So what's happening is name is just getting set back to name, and level is getting set back to level. None of these instance variables are being used at all. So what is the solution of this problem? Well, Java has made this keyword. So what we do is we just do this dot name and this dot level, and whenever you use the this keyword, it's saying use the variables that are actually defined in the class. So this is just an explicit way of telling Java that we want to use these variables. You can also use this for methods as well. So if we want, for some reason, we could actually call this dot attack in the constructor. Now I'm going to explain the static keyword. So the static keyword means that the object belongs specifically to the class instead of instances of that class. So let's make an example. We will go to the Pokemon class and create a static variable. So to make a variable static, we just use the static keyword. And then let's make it a number of Pokemons. So let's go to the main class and get rid of all of this and call our variable. So the cool thing is that the static variable is owned by the class. So we won't have to create a Pokemon object to use it. We could just type in Pokemon.number of Pokemon. So if you print this out, it would be 0 because we didn't use this variable in anything yet. So now let's create some Pokemon objects. So now we create our first Pokemon, which is going to have the name Eevee and the level of 25. Now if we print this again, it will still say 0 because we haven't done anything with the variable yet. So now let's go to the Pokemon class and increment it each time by 1, every time a new Pokemon object is made. Now we run this again, it will still say 0. That's because we need to initialize the object before we can print the number of Pokemon. So if you run now, it will say 1. There we go. Now to test this even more, we copy and paste this and make a second object and change the name to Pokemon. Add the third object and name it Bulbasaur. And obviously change the object names. Now if you run this again, it should say 3. That's because we have created 3 objects. Now it's entirely possible to access a static variable using an object name itself. So let's replace Pokemon with P1. It's possible to access this static variable using the named instance, but it's not recommended. As you can see, there is a warning: static member Pokemon.number of Pokemon accessed via instance reference. So it's the best practice to type in the name of the class that owns the static member, followed by the static member that you're trying to access. So what do you think would happen if we remove the static modifier from this variable? For one, we can no longer access this variable in a static way. So you can see that it says cannot make a static reference to the non-static field. Number of Pokemon cannot be referenced from a static context. So this means that each of these Pokemon objects has its own number of Pokemon variable. And in order to display one of these copies of the number of Pokemon variable, you would type in the name of the instance of this class, for example, P1, and their own number of Pokemon, which is 1. Same goes for P2 and P3. So if we change this back to static, we can make a static reference to this static variable, and this will display the total number of Pokemons that we have created from this class, which is 3. We can also apply the static keyword modifier to a method. So let's create a static method that returns the amount of Pokemon that we have within a message. So let's use the static keyword void. It's going to return nothing, and then display Pokemon, and within the method it's going to system out.println you have plus number of Pokemon plus Pokemons. Now the preferred way of calling this method is by the class name itself, not the name of one of its class instances. So we're going to type Pokemon dot, and as you can see, display Pokemon, and when we press print, it's going to say we have 3 Pokemons. We just need to fix the space thing. And then run again, it should say yes, you have 3 Pokemons. And if I add a 4th Pokemon by the name Pikachu, and run again the display Pokemon method, it should say you have 4 Pokemons. Now we're going to talk about overload. So overload is using the same method but with different attributes. So let's go ahead and go to the Pokemon class and use the attack method. So we're going to copy it and paste it in the same class. So when we paste it, we're going to face an error, and it's going to say that name of the method is already defined in the name of the class. So in this case, attack is already defined in Pokemon. So now we go to the method we just pasted, and inside the parentheses, we add a new parameter. So in this case, I'm going to say int power. And as you can see, the error is now gone because we use new parameters for the same method name. Now we need just to change what's going to be printed in the new method so we can be able to distinguish between the two of them. Now we go to the main method and make a new object. Now we run the method with no parameters. It's going to do the usual thing and print the name of the Pokemon plus attack. Now we do the same thing, but type in the number of power we need to use in the attack. We're going to type 100 and then run. Now we're going to see 2 different outputs. The first one is from the normal attack method, and the second one is from the method we just made. And that's what method overloading is all about. Now we talk about inheritance. Inheritance is the process where one class acquires the attributes and methods of another. So here's an example. I have my class that contains my main method and an additional class that's called Pokemon. Now let's create a new class and call it Legendary. This class is going to be dedicated to the legendary rarity Pokemons. Now, what I would like to do is have my legendary class inherit everything from the Pokemon class. So in order to use inheritance, when you define the class, we're going to add extends, and then the name of the class you would like to receive everything from. So legendary extends Pokemon. So here we're going to face an error. It says that there is no default constructor available in Pokemon. That means that Pokemon doesn't have a constructor with no parameters. This also means that we have to match the 2 constructors with a super keyword. So let's go ahead and create a constructor for the legendary class. So now we type legendary and then go back to the Pokemon class to match the parameters. So string name and int level. So we type string name and int level inside the parentheses. And inside the curly brackets, we type super as a method. And inside the method, we type name and level. And that's how we match the 2 constructors. Now we create a legendary class object. And the name is going to be Mewtwo and level 100 because it's legendary. Now if P1 used the attack method, it's going to say Mewtwo attack. This is because the attack method is in the parent class Pokemon. Now let's print out the p1.name as if name is a variable from the legendary class. This is possible because legendary is descendant of the Pokemon class. So this means it has a name variable and a level variable and an attack method. So that's one of the benefits of using inheritance. For one, you don't need to list all of these attributes and methods twice. Now another benefit of this that we can have this legendary class have its own unique additional attributes and methods. So let's create a new class and call it Mythical and extend that to Pokemon. Now we automatically create a new constructor because it's going to take time. Now, since not all legendary and mythical Pokemons are the same, there are two completely different objects. So, for instance, mythical Pokemons are only obtainable and legendary ones are only catchable. So let's create a new variable for mythical. It's going to be Boolean and it's going to be obtainable. We have to set it true in the constructor. And let's do the same for legendary, but let's call it catchable instead. Now let's go to the main class and create a new mythical object. Let's call it P2 with the name Eternus and with the same level 100. Now let's get rid of this and south P1 dot, it shows it automatically catchable, and south P2 dot obtainable. That's why we initialized them to be true. Now here we can see that catchable is unique to the legendary class and obtainable is unique to the mythical class. So let's say if we replaced catchable with obtainable, it's going to give an error that it cannot resolve symbol obtainable because it does not exist in the legendary class. And same goes with the mythical class. If we replace obtainable with catchable, it's going to give us the same error. That's because catchable does not exist in the mythical class. Now we're going to discuss what method overriding is. So method overriding is making a method in the subclass that is already present in the parent class. And this is done so that the child class, aka subclass, can have its own implementation. So we have two classes, Pokemon and Legendary. And as you can see, Legendary extends Pokemon. This means that Legendary is a child class and Pokemon is the parent class. And if we return to the main method, you will see that I already made an instance variable with the legendary class. Now, if we did p1.attack, it will print out this name plus face attack. We can run it too. Here we go, the name of the Pokemon, which is Mewtwo, attack. Now, what we could do is we could give legendary its own implementation of our method, attack. So it's going to have the same name, attack. We just have to copy it and paste it in legendary. So what we just done is called method overriding because we're giving the legendary class its own implementation of the attack method, and we can have this method do something more specific about the legendary class Pokemon, such as legendary plus the name plus attack. And if we go back and run this again, it's going to say legendary Mewtwo attack. Now our attack method within the legendary class is considered the overriding method, and the one that it inherits from its parent class Pokemon is considered the overridden method. So if we are overriding a method, the overriding method should have this annotation on top. This isn't necessary, but it's considered a good practice. And if we go back to the Pokemon class, you can see that it has override on top of it. If you click on that, it's going to send us back to the attack method in the legendary class. Now, if we were to create a Pokemon object this time, let's call it P2. And we use the attack method, it's going to use its own implementation of the attack method, which just states that the name of the Pokemon attack. If you use P1, which is from the legendary class, it's going to display legendary name of the Pokemon plus attack. So each class is going to use the method that is more closely associated with it.